binding the troponin C. Okay, as it binds the troponin C, you have now the sliding of your tropomyosin, okay, exposing the myosin binding site. The myosin that is now in a high energy conformation will bind now to actin. Okay. Why will it bind to actin? Because it is now exposed. Okay? And you know that myosin has a very high affinity to actin. Okay? After the binding, it will now hydrolyze ATP and it will now produce the swiveling, okay? The cross-bridging and swiveling of the head, producing the power stroke. Okay. So each power stroke shortens the muscle by 1%. Now in order to remove, okay, the myosin, it has to have ATP. It binds and disengages it, okay, and converts it again to a high energy conformation. Okay. So yeah, high energy conformation. Okay. After that, the calcium will be pumped back, okay, to your sarcoplasmic reticulum. Okay. By ion pumps. Now, what do you call that pump? So it is also an active transport. Simple calcium pump lang yan. Because calcium is abundant here than outside. So kailangan ng force to go inside. Okay, so ATP is needed. Okay. Then it pumps in the calcium. That is not logical that the mitochondria must always be there to supply both contraction and the pumping of the calcium channels. Okay. So in other words, a single cross-bridge cycle requires how many ATP? At least two. One for binding, swiveling, and the unbinding. Isa lang yun. And one for the calcium. At least two. Okay. Okay, so we know that already. Ayan. Now let's go for multiple. Okay. Marami na sila ngayon. Here we have four. Four that are in the high energy conformation. Okay. So what do you think will happen? If an action potential releases calcium, binds now to troponin C, swivels, slides laterally, the tropomyosin exposes all of your myosin binding site, what will happen here? Will everything bind?
Lahat ng active, lahat ng high conformation.
Oh yeah, lahat ng high conformation. So lahat, they will bind. Lahat sila. Yes?
Paisa-isa.
Gagapang. So the question is, lahat ba sila?
Yes, sir.
Remember that myosin has a very high affinity actin. And they are all in the high energy conformation. What do you think, John Ray? Yes? Actually, no. Let's see.
Paisa-isa. Paisa-isa.
Okay, bakit kaya? Lahat naman exposed na eh. Bakit hindi kaya lahat sila nag-bind?
Walang gagalaw. Hindi gagalaw.
Ano? Okay, that's one. Pwede yan. Hindi naabot yung actin. Meaning, this binding site here for this myosin is not in perfect alignment. Okay? It's not in perfect alignment. Kaya kahit na-expose siya, gusto niya mag-bind pero hindi niya abot. This one first will bind. So pag nag-bind siya dito, exact na siya dito, siya naman mag-bind. So pag nag-swivel siya, exact na naman doon sa kabila, siya naman mag-bind to shorten. So if you add them all, they will pull the actin together. You can just imagine kung lahat sila magbabind o isang tank. So what will happen? Wala, lahat lang. Movement, 1% lang. Do you understand? So not all of them will bind at the same time. And the reason there is perfect alignment. Okay, alignment is necessary, which is good. Because if they are not in perfect alignment, it means that the other one would have to pull the muscle in order for a perfect alignment for the other to bind again. And would thus shorten the muscle further. Okay? You understand? So every time that you're going to flex your biceps, you imagine this. Every time you carry your books, snail. Snail, si Gaito, si Gano. Imagine this. Okay. Every time you walk, every time you step, ito yung mga cross-bridging na quadriceps.
Laging may sound sa upak mo.
Laging may sound.
Naglalakad kayo.
Okay, so here you have a person in the route.
Dates.
Yan leg press eh.
Leg press.
Tawag namin siya, leg press. NK day ko na tawag na. It's an NK day. Okay, so we have the contraction to blink. Okay. So click the thin filament to see contraction. So you can see outwardly.
Ang kulit.
Tight ata glutes niya eh. Tight ata hamstrings niya.
Pero may mali dito. Ano yung mali? Yes. Hindi, huwag ka Mr. Rama. Very good ka na.
Yung ano po, parang hindi niya hin-hold yung in contraction po, parang hindi nagsistay, parang link yung myosin head po sa akin.
Come again?
Parang parang sa stable na contraction. In mid-contraction, bago niya i-release yung contraction, hindi nag-stay sa maganda yung ano, yung myosin head sa
In mid-contraction.
before release, yung holding.
Okay, holding. So dapat,
Parang ano pa rin, parang bound pa rin yung ano, yung mga myosin.
okay, pound pa rin dapat yung myosin. Okay, so ito yan. Okay. Kita nyo on the mid-range, yung fully extend na siya, going to relaxation. Biglang bumitaw lahat ng myosin mo. Kita nyo? One more time.
Dapat
That does not happen. Okay. Dahil pag bumitaw lahat yan, biglang babae.
Drop, like,
Biglang
Kasi may weights yan eh. Kahit na walang weights yan, even your extremity weight is heavy enough. So pag nag-contract yan, so nag-swivel yan. Then afterwards, pag bumitaw yan, ganyan malalabas yan. So in other words, when your muscle is relaxing, actually not really relaxing, when contraction is finished, okay, going back to the resting position, your myosin is still binding. Okay, yun nga lang, okay, it is binding also, pero this time it is binding while lengthening. Okay, why is that so? In order to prevent injury. Okay, your myosin also prevents gravity from exerting itself. Okay, and this is what we call contraction while lengthening is eccentric contraction. Contraction while shortening is concentric contraction.
Is that due to the stretch reflex?
No. No. It's not due to the stretch reflex. Kasi pag stretch reflex yan, dapat concentric yan. But you are actually contracting while you are lengthening in order to prevent or to avoid injury.
Sir, what if you hold the weight to steady does the athlete myosin hold themselves?
Correct. Yes. It holds themselves. And you call that what he mentioned as maintained contraction. What do you call that? Tetanic, yes. ISO. Met. So pag the mid, minintay niya yung mid-range in full extension. So lahat sila nakatabi. Kung sino lang ang perfectly aligned. Yun lang ang katabi. Okay? Then afterwards, if you're going to release it, okay, alternate din sila ang release. Okay? Then contract again. Then release. So isip, pagod na pagod ang myosin. So imagine if you are an endurance runner, running 10 K. No wonder that they're going to hit the wall. The expression, hit the wall. Okay? At the 18th, 19th kilometer. It's because of loss of ATP. Do you understand? Okay. Yeah, so ATP is for the power stroke. Is to disconnect the cross bridge and to actively transport calcium ions. Okay. Essentially, you only need how many ATP minimum? 2. Okay. 2 moles of ATP. Single bridge contraction. Pero pag multiple, it multiplies. Okay, very good.